This video is presented by Choon and Choon Yi. In this video assignment, we are discuss about the differential equation. What is differential equation? The differential equation is a mathematical equation that relates some function with its derivative. Second, we look at the property or characteristic of ordinary differential equation. The differential equation we often write in this form: y prime plus pty equals to gt. In this differential equation, we also call it as the first order linear differential equation. A first order differential equation that cannot be put in this form, we call it as a non-linear. If gt is equal to 0, then it is called homogeneous function. If gt is not equal to 0, then it is called non-homogeneous function. We look at the example. We compare this equation with this equation because the y prime plus pt, the pt is negative t, y equals to sin t is gt. So this form is similar with this form, so we call it as a linear and non-homogeneous function. We look at the example 2. The y prime similar with this negative ty square, because here is y square, so this equation is not similar with this equation, so we call it as non-linear and non-homogeneous function. We look at the example 3. Y prime similar with this negative ty, the pt is negative ty, is equal to 0. gt is 0. So from here we know that when gt is 0, this is called the homogeneous function. So this equation is linear and homogeneous function. Example 4. Y prime minus ty square is equal to 0. The y square here is not similar with this, so it is non-linear and homogeneous function. Now we are going to discuss about the necessity of the constant for indefinite integral. Now we are going to look about this example. Given a ball is bouncing in a harmonic motion with v equal to 2 sin t cos t, then find the equation of the displacement. We know that the integration for 2 sin t cos t is equal to sin square t plus c, or negative cos square t plus c. Then we can convert negative cos square t equal to sin square t minus 1. Then if we ignore the constant c, which is assumed that c is equal to 0, when t is equal to 0, we get the displacement which is equal to 0 for equation 1 and negative 1 for equation 2. We know that displacement cannot be a negative value, so that we can satisfy the requirement of the question. Now we are looking about the solution of first order differential equation. Given the question is dy dx is equal to negative 4y. For solving this differential equation, this one we move the variable y to left hand side and x to right hand side. So we will get dy over y equal to negative 4 dx. Then we integrate both sides, we will get ln y equal to negative 4x plus c, where c is a constant. In this form, we call that it is a general solution. Then we let there is an initial condition y equal to 5 when x equal to 0. We substitute y equal to 5 and x equal to 0 into this equation. Then we move the ln to the right hand side, we get y equal to e power negative 4x plus c. So we will get 5 equal to exponent power negative 4 multiplied by 0 plus c, which is equal to 5 equal to exponent power c. Then we will get the c value is equal to ln 5. So the final answer is ln y equal to negative 4x plus ln 5. Now we are looking about the solution of second order of differential equation. Given the question is d2y over dx squared plus 2 dy over dx minus 3y is equal to 0. For this question, first we are write down its characteristic equation, which is a squared plus 2a minus 3 equal to 0. We know that from here, we get the value of a is equal to 1, b is equal to 2, and c is equal to negative 3. So from here, we substitute these three values into the equation b squared minus 4ac. We will get 16. Since d is greater than 0, so we know that this equation has two distinct roots. For this equation, we can factorize it become a plus 3 multiplied by a minus 1 equal to 0. So we will get the value of a is equal to negative 3 and 1. The general solution to the given differential equation is given by y equal to a exponent power a1x plus b exponent power a2x. So the answer is, we substitute the a1 and a2 into this general solution, we will get that y equal to a exponent power negative 3x plus b exponent power x, where a and b are constant. Now we let there is an initial condition y equal to 0 and y prime equal to 1 when x equal to 0. So from here we substitute that x equal to 0 and y equal to 0 into this equation. We get that equation 1 is a plus b equal to 0. For y prime, we differentiate the equation y equal to a exponent power negative 3x plus b exponent power x. We get negative 3a exponent power negative 3x plus b exponent power x, which is equal to 1. Then substitute the value of x equal to 0, we get the equation 2, which is negative 3a plus b equal to 1. From equation 1, we can convert b equal to negative a. Then we substitute b equal to negative a into equation 2, so that negative 3a plus negative a equal to 1. And we get the value of a is equal to negative 1 over 4. Then we substitute the value of a into b equal to negative a. We get the value of b is equal to 1 over 4. Therefore, the final answer is y equal to negative 1 over 4 exponent power negative 3x plus 1 over 4 exponent power x. There is some method to solve the ordinary differential equation. The first method is method of separation of variable. The second method is integrating factor. And the third method is by using substitution. Now we look at the example of method of separation of variable. The given example is dy dx is equal to 4x exponent negative y. We separate y to the left hand side and x to the right hand side. So we get the form like this. The y variable is at the left hand side and the x variable is at the right hand side. Then we integrate both sides, we get the final answer in this form. And then we move the exponent to the right hand side, then we get the y equal to ln 2x squared plus c. The second method is integrating factor. Usually the first order linear differential equation is in the form y prime plus pxy equal to gx. The integrating factor f is equal to exponent power integrate px dx, where the px is get from the general equation of first order linear differential equation. To solve the differential equation, we multiply both sides with integrating factor. Now we look at the example. dy dx minus 2y is equal to exponent power 4x. From here, we compare with this equation. We know that the px is equal to negative 2. So the integrating factor is equal to exponent power integrate negative 2 dx. So we get the integrating factor is equal to exponent power negative 2x. Then we multiply both sides with exponent power negative 2x into this equation. And then We solve this step by step, and then finally we get the y is equal to 1 over 2 exponent power 4x plus c exponent power 2x, where c is the constant. The third method is using the substitution. Usually we are using the substitution y is equal to vx to solve the differential equation. We look at the example, dy dx is equal to 3x minus y divided by x. We substitute vx into y, we get dvx over dx equal to 3x minus vx over x. From here, we using the product rule. We get v multiplied by 1 and then plus x dv dx equal to, here we can factorize it, it's become x multiplied 3 minus v over x. Then we solve this step by step. We will get back the general equation of the differential equation. From here we know that the px is equal to 2 over x. So we using the integrating factor method, which is equal to exponent power integrate 2 over x dx equal to exponent 2 ln x, and then equal to exponent power ln x squared, which is also equal to x squared. And then we multiply both sides with x squared. Then we multiply both sides with integrating factor into this differential equation. We will get x squared dv dx plus 2xv equal to 3x. And then we solve it step by step. Finally, we will get vx squared equal to 3x squared over 2 plus c. From y equal to vx, we can get v equal to y over x. And then we substitute v equal to y over x into this equation. We will get y over x multiplied by x squared equal to 3x squared over 2 plus c. And then finally we will get y equal to 3 over 2x plus c over x, where c is the constant. That's all from us. Thanks for watching.